All attendees are in listen-only mode.
Welcome, everyone. My name is Tracy Fitzpatrick, and I'll be your moderator today. Thank you so much for joining us here at NetCom Learning, a market leader in promoting lifelong learning, training, and talent development solutions. We are very excited to host today's webinar, 5 Things You Should Know About Big Data. And presenting today's topic is Tarun Sukhani. Tarun is a business and IT professional with over 19 years of experience working in multinational companies. He's conducted training as well as facilitated training workshops in areas of project management, consulting, leadership, management, and other soft skills. In addition to enterprise computing programming, big data, data science, and machine learning. Now, please bear in mind that this is an overview of a very robust topic. We do offer a collection of technical and business courses that can be tailored towards your specific requirements. If you are interested in a further discussion, you can make an appointment with our learning consultants through our website at netcomlearning.com. Today's session is also being recorded, so you will get free access to the recording in the next 24 hours via email. And now I'd like to invite Mary Feeney, Director of Corporate Learning here at NetCom Learning, to discuss some values and important items. Mary, go ahead.
Thanks, Tracy. NetCom Learning helps customers build innovative learning organization by achieving a smarter workforce that can adapt to change and help drive growth. We do this by teaching technology, business, and manage learning processes. Our global delivery capabilities enabled us to reach more companies in more than 50 countries. Since 1998, we have been empowering organizations with our managed learning services to help them reach optimal performance results and address challenges. We have 9 practice areas in which we specialize. They encompass people, process, and technology training. Today's presentation is from the Data and AI practice area. NetCom Learning offers a comprehensive training portfolio for big data courses. Here is our upcoming class on our public schedule. We have HTTP Analyst Data Science that's scheduled on March 6, Microsoft Class 20774, Performing Cloud Data Science with Azure Machine Learning, which is scheduled on the 19th of March. Data Engineering on Google Cloud Platform, that is on March 19, and Google Cloud Fundamentals, Big Data and Machine Learning, that's on the 23rd of March. We can also deliver private training to your teams and can customize the content based on your specific needs. Schedule a free training consultation to assess the skill gaps to determine possible solutions. Going back to our public classes, you can find more of these courses by simply searching our website at netcomlearning.com. And with that, I'll turn it back to you, Tracy.
Well, thank you so much, Mary, for all that vital information. So why should you all attend this webinar today? The revolutionary growth of internet connectivity, cloud computing, and enormous devices being used to exchange the information has led to generations of huge data sets, bases worldwide. Big data, as it is referred, is the greatest challenge to capture, store, and manage securely and efficiently. Proficient data analytics and effective storage of data with ease of access from anytime, anywhere are some of the primary features that are making big data recognized at the global level. This webinar takes you through big data essentials that you must be aware of in case you intend to work in data management analytics. Now I'd like to give you a quick overview of the logistics before we get started. To begin with, you do have the option to adjust the window size to your liking. Simply hit the escape key and find the zoom button on the top left corner of your GoToWebinar viewer. Everyone has been muted except for our presenters. Please feel free to submit any questions you do have for the presenters here in the questions pane, and we will address them at the end of the session. A PDF copy of today's slides are also in the handout section of your GoToWebinar viewer. And now I'm going to pass this over to Tarun, who will be presenting today's topic. Go ahead, Tarun, you're live.
Okay, can everyone hear me?
You're good.
Okay, great. Okay, so today I'll be covering 5 things you should know about big data. So basically, those 5 topics encompass what was noted in the website that I believe that you should have looked at. So I'll go through all of those 5 topics with you. So let's start off with what is big data. So the basic idea behind this, phrase big data is that everything that we do, increasingly leaves a digital trail. So whether we visit, e-commerce websites or we're doing social media, or even if we're doing, things that we typically associate with offline activity, like for example, visiting a brick and mortar store, or just attending an event, a public event. All of that stuff is leaving a digital trail. And the goal of big data is to measure, and store and analyze that digital trail. So I'm not going to go through all of this. Obviously, we don't have time. But moving on to the next slide. Basically, big data encompasses 5 what we call V's, and they just start with V. So basically, the first one I'll cover is volume. So in order for something to be considered big data, it generally has to have these so-called 5 V's. So the first one is volume. So volume is obviously the amount of data you have, right? So if you have a lot of data that you normally collect, um, whether it's on a daily basis or yearly basis or whatever, then chances are you have what we call big data. So that could be, petabyte or exabyte range or whatever. Velocity. Velocity means that you may not get, like, for example, a lot of data with each transaction. So maybe you're only collecting, let's say, a megabyte of data or less per transaction. But if you're doing millions of transactions, a month or even a day, obviously after a year, it's going to be huge. So velocity also makes a huge difference. So we see this a lot, for example, with website analytics, like with ClickView and stuff like that, Clickstream, where we're basically, surfing a website as an individual buyer, and we're just generating massive amounts of data per buyer. And that is if you take the millions of people who could be using that site, I think you get the idea that every second or every minute we're generating tons of data. Variety is the different types of data that we're generating, and by type, what I mean is, like, in the old days, in the Web 1.0 days, for example, of horrible looking websites, we would consider that to be horrible today. But basically, they're mostly textual, right? It was mostly about transfer of information and knowledge. And today it's mostly about consuming media and producing media. And what has changed really, that that has made big data kind of a buzzword, in the fact that with Web 2.0 and onwards, the buyer or consumer, or whatever you want to call that person, is generating their own data. So rather than relying strictly on an authoritative source, we as individuals are generating data on a daily basis, through e-commerce and social media and so on and so forth. So, and it could be pictures, it could be, video, it can be, normal kind of different data structures, data types, and so on. I'm not going to go through all that XML JSON stuff, but I think you get the point. And then finally, we have veracity, which is basically fake news right now. So veracity is about, yeah, I mean, actually it is about fake news to some extent. It's basically about the quality and the source of the data that we have. So, would we believe a non-authoritative source, right? So if it's generating information, generating data, or it could just be, like, for example, an IoT sensor, right? So if we have an IoT sensor and it's misplaced, well, can we rely on that data? Probably not, right? So we'd have to make sure that the quality and the source of that data are also correct. And then finally, if we add up all these 4 things together, we get what we call values, the so-called 5th V. So this is just another way of looking at the same thing. But basically, what is the purpose of big data? And the goal really of big data is to improve our analytics and statistical models. So big data is often an input into data science. And in fact, they call it big data analytics. And what we've noticed is that the more quality data that we have, that's a mouthful. In other words, if we have a lot of good data, the better our data science models will be. You know, our for example, our logistical regression models or our neural network models or deep learning models, they will just be more predictive. And the other advantage, of course, is that if we can couple that with IoT, you know, then basically we don't have to worry about gathering that data manually, and it'll already be in the right format, you know, ready for insertion or ingestion into any of our statistical or, you know, machine learning models. So big data is often associated with these type of massively parallel, highly scalable, and highly available type of data storage volumes. So we often talk about like Hadoop or S3 or OneDrive or one of these type of, you know, distributed storage solutions out there. But as we'll see, that's only half the picture. So storage is only half the picture. The other half is, of course, parallel compute. Okay, so this is the growth of big data. So as you can see, there's been an explosion, if you haven't figured that out by now. And a lot of that explosion really is being driven by IoT. So these IoT devices everywhere, these sensory devices, for example, or even if you look at, for example, you know, the growth in autonomous vehicles, right? That's generating terabytes of data, you know, like per drive. Like you just take a simple drive to the store, that could like generate a terabyte of data, right? So you can imagine what type of useful data could be, you know, in all of that, you know, terabytes of stuff. And then the graph on the right shows the share of the data that's being generated. So of course, as you'd expect, North America and Europe kind of dominate. It kind of follows GDP figures as you'd expect. But I'm actually from Southeast Asia. You probably can't tell, but we're not even on the map. So a lot of countries and regions still have to, you know, work their way into this chart. Okay, so there are quite a few categories of big data. I'm not going to go through like everything in detail, but I'll cover a couple of them just so you get the idea. So one type is activity data. So activity data is the stuff that we do on a daily basis, right? Whether we're doing it online or offline, you know, buying stuff, listening to stuff, watching stuff, you know, Netflix and stuff like that. Well, you know, whoever is providing those services is monitoring us. They're tracking us. They're storing all that data, and they're using that, hopefully, you know, to make better recommendations to us and to make our lives more convenient. Then there's conversation data, right? So this is, you know, what we typically would you know, kind of consider surveillance sometimes, but it doesn't have to be nefarious. So it could be just, for example, you know, what Gmail does, which is, you know, when you know, have emails about stuff, the algorithm says, hey, you know, here's some savings on trips or something. Or it could be, you know, you're using Facebook and yeah, it does the same thing. But it can also be, for example, you know, offline with just normal phone conversations. What we see happening is you always see that message, you know, you're going to be recorded for quality purposes, blah, blah, blah. Well, some of those calls are actually being digitized, and then the algorithm, you know, will convert it from speech to text and do NLP on it, you know, and then it'll actually figure out if that interaction was positive or negative. Okay, so these are some of the domains where big data is being applied. Of course, digital marketing is a big thing, as I mentioned, about web analytics like clickstream stuff. Then there's data exploration and discovery, fraud detection prevention. I actually did a fraud detection solution for a money services business, back in the day, like several years ago. And that, of course, took advantage of big data. Basically, it was coming from our log data. Then we have social network and relationship analysis, machine-generated data analytics. This is what we normally associate with like IoT kind of stuff. And then we have data retention, and I worked for that. I told you about that fraud detection thing. Well, that same company also had data retention requirements. These are regulatory requirements oftentimes that banks and other financial institutions have to comply to. And so big data is great for that too. We can store like umpteen years worth of data, and we can just keep on, growing our nodes, expanding our data storage, and it's not very difficult to do, especially on the cloud. Okay, so let's take a look at some use cases here. So there are a lot. So some of this kind of overlaps with what we saw on the previous slide, but this kind of gives like actual applications, right? So I mentioned fraud detection, but there's a slew of them. I'm not going to go through obviously all of them. Okay, so what are the top 10 big data sources? So in other words, where do we get our data from? And this is like kind of like the top 10. Of course, Web 2.0, right? Social networking. Then there's what I just mentioned in the previous slide about activity-generated data. Then we have cloud apps, public web information. So you leave a trail, right, when you surf the web. So there you go, right? Google knows that. MapReduce results. So MapReduce is the parallel computation part that we'll cover later. Data warehouses, NoSQL databases, and so on and so forth. Okay, so a lot of people get overwhelmed by big data because it's big, right? No. So the data is big, and the number of applications apparently is big too. So these are just some of the applications. In other words, some of the software tools that have been developed to work on big data. But basically, these can be grouped into major categories. And so those major categories are basically parallel and distributed storage, parallel and distributed compute, all the tools that are used to simplify storage and compute rather than writing everything by hand in very long code. And then there's data ingestion. In other words, getting the data into storage for computation purposes. And then there's NoSQL databases, data analytics, and data visualization. So those are like the major categories, and it's kind of hard to see on the slide on the right, but if you paid attention to what I just said, I think you get the idea. Okay, so big data is kind of dominated by what we call Spark Hadoop ecosystem, or the Hadoop Spark ecosystem. And the reason for that is historically the first kind of commercially available open source big data solution was and is still Hadoop. And Spark has kind of taken a lot of attention away from Hadoop because Spark is used for real-time big data processing. And so a lot of companies really like that. They really like real-time processing because it helps them with e-commerce, with IoT, and basically being able to react to streams of data coming in near real time. So that has become really popular, over the past few years, or even a little bit longer. It's already 2018. So, but it all started with Hadoop. So this diagram just kind of shows you the interrelationship. And of course, we'll cover some of these components. But since we're on this slide, I'll just mention a few points. So at the core is HDFS. That's our distributed storage. Okay, and then we see that Hadoop is on the left and Spark is on the right. Hadoop basically has a resource manager that keeps track of all these distributed resources, these distributed kind of machines that make up the entire cluster, and that's managed by Yarn. And then we have these things that are built on top of HDFS, like Pig and Hive. And then on the right-hand side, you've got the same thing. You've got kind of like the Spark core, and then around that, we've got the tools built around the Spark core that allow you to do all of the analytics and all of the kind of streaming of data. Okay, so I talked about that basically big data is two things. It's distributed storage and compute. So let's talk about the first part, which is distributed storage. So distributed file systems really have their history in supercomputing. So back in the day, in the university labs and stuff like that, researchers were working on how do we take individual machines and combine them together through networking in order to get kind of like a virtual, machine, a machine that basically combines the resources of the individual machines into like one type of shareable resource. And that was kind of like the beginning of what we call grid computing. And grid computing is exactly what cloud computing is, that we call it. We call it cloud computing, but it's really just grid computing. And so these supercomputing systems had a distributed file system. And the idea was to combine the storage of these individual machines into one type of like mass storage. And you would reference it as if it were like a single drive. But of course, it's not. It's storing the data on those individual machines. And so that those individual, data, that were stored on machines were sometimes called shards or chunks or blocks or whatever. So even to this day, for example, in Hadoop, we call them blocks. In some NoSQL databases, we call them shards. So it's all the same thing. All these NoSQL databases are basically distributed file systems. Okay, so if you remember from what I said in the first few slides, I talked about the 5 V's, and I mentioned that one of the 5 V's, right, is variety. So variety basically means, just to reiterate, is the different types of data that we have. So we could have unstructured, structured, or semi-structured. So this is just talking about unstructured data, and the great thing about big data and working with distributed storage oftentimes is, well, we can store different types of data. We're not limited to what we had with RDMS, where it had to fit a particular data type. And often that data type was not an image or a video or audio. Oftentimes it was simply text. So now we have the full brunt. We can store any type of data in distributed storage. Okay, so as I said, NoSQL databases build on top of distributed storage, and they offer certain features. And there's different types of NoSQL databases. So, for example, column-based databases like Cassandra or HBase. HBase, by the way, is part of Hadoop. Or key value stores like Redis or React. Or graph databases like Neo4j, or document-based databases like MongoDB or CouchDB. Okay, so let's get into now, the most popular big data system, the one that kind of started it all for, commercial open source solutions, and that's Hadoop. Now, Hadoop has a long and storied history. I could never do it justice in such a short period of time. And over the years, a lot of applications have been built on top of Hadoop. A lot of tooling has been created for Hadoop. But the point is just distributed storage and compute. So here's, one definition. There's many, of course, out there. Okay, so what is Hadoop used for? Well, we already talked about this as well, but it's used for, searching massive amounts of data, log processing, recommendation systems, like on Amazon, Netflix, analytics, video and image analysis, and data retention. Okay, so what makes the Hadoop platform a big deal? Okay, what makes it a big deal is that the so-called parallel computation that I'm talking about actually happens on the data that is local to that machine. So it's actually doing all the computation on only the data that's on its particular drive on that machine. And if we combine that with all the other machines in the cluster, basically it's massively parallel. So imagine, for example, that we need to do a batch job, right? That, for example, calculates what is the profit for our e-commerce transactions for that day. Well, we could do it on one machine and maybe go over millions of records. Maybe that takes 45 minutes. Well, what if we distributed that and we took those million or whatever millions of transactions and we split them up, let's say over 100 machines or 1,000 machines, right? So then maybe we're only dealing with, thousands of transactions per machine or tens of thousands of transactions per machine. Well, to calculate profit on thousands or 10,000s on a single machine is not a big deal, right? So let's say it takes only, let's say 5 minutes to do it on each machine. Well, the total amount of computation time then will be a little bit over 5 minutes because now it's done in parallel, right? So it's really only how long it takes one machine to do it plus some overhead. So you can see we saved 95%. So it's a huge deal in that sense. And so this kind of illustrates it, a little bit better, whatever I just said. This kind of illustrates it really clearly. You can see here that we're using a bunch of different data nodes. Each one is doing a computation, right? So if each one takes 5 minutes, I think you can imagine that we're going to save a lot of time. The other thing is that big data has what we call a shared nothing architecture. So what does that mean? So that means that, as I said, each computation happens on its own individual storage, its own individual disk storage. And then the results are combined together. And so that way we don't have to worry about shared disks, right? Because if something happens to that one disk, well, we're messed up, right? We're screwed. And we don't have to worry about that for big data. Why? Because what big data, what Hadoop will do is it'll do replication. So whatever we store, that little block will be replicated to the other machines. So if we lose, for example, any particular node, any particular machine, it's not a big deal. We can get the data from the other machines. So it has built-in fault tolerance, which is also a great deal. It's a big plus. So it's kind of like we're killing two birds with one stone here. So it's a real advantage. Okay, so this is kind of like a more I would say streamlined view of that diagram that we saw earlier, and it shows you some of the major tooling that we normally see in Hadoop and its ecosystem. So at the bottom, we have distributed storage. And at the top, we have the different categories of tooling. And they all rely on HDFS in order to do their work. Okay, so let's talk about parallel storage and compute. So in Hadoop, parallel storage is called HDFS, and parallel compute is called MapReduce. MapReduce is basically straight from Google. So Google published a paper upon which Hadoop is based. And Google basically wrote a paper that outlined how they actually do it, how they actually do their search. And they said, well, we use MapReduce. And MapReduce is basically from Lisp. Map and reduce are two separate Lisp functions. And what map does is it takes some input and maps it to some output. And what reduce does is take all of that mapped output and combine it together or aggregate it together into a final output. And that's exactly what those machines are doing in that cluster, those individual machines. They're running map jobs. And there could be, for example, one or more machines running reduce jobs. that are combining the results of that mapped output from each of those machines into one final result. So I'm not going to go into all the details on the slide, but let me just say that over here, the stuff in yellow is HDFS, and the stuff in purple or blue or whatever color it looks like to you here is for MapReduce. And so we have a master node that oversees those individual machines, those individual nodes in our cluster that are actually doing the individual storage and compute. This is just another way of looking at it. This just tells you how HDFS works. So you can do a read, which will obviously read from the individual nodes and combine it all together. Or you can do a write. And of course, what a write will do is the opposite, which is it'll take a file and break it up into blocks or chunks or shards or whatever you want to call it, and put that into the individual machines. When you run MapReduce, it'll run it on the blocks or shards only on those individual data nodes. And so this kind of shows it, right? So you can see that we're doing map and reduce, and we're doing it on the individual nodes. And then the results are combined together. This is a typical example of MapReduce. This is the canonical example, and it's called word count. So imagine you have a bunch of input files, like you could have millions of these things. And what's going to happen is you're going to have a mapping phase. And what happens in the mapping phase is it's going to take each line from those input files and create a output from that. So this is our input key value pair, right? The key is our line number and the value is our line. And it's going to create an output or intermediate key value pair. And this is our mapping phase. So it's going to produce, for each word, it's going to put a 1 after it. So we have apple 1, orange 1, mango 1, and so on and so forth. And what we do is we combine the results. Well, actually, we group it by the key. So here, for example, we have apple. We have maybe other apples here too. Here's another apple, and here's 2 more. So let's combine kind of group all those keys together. So we have apple 1, apple 1, apple 1, grapes 1, and so on and so forth. And then what do? We aggregate, we reduce. And that's the reduce phase. And so we say apple, add up all the apple values. So what's that? That's 4. And we do that for each of the keys. And then we get our final output, which is what? The individual unique keys with their values, with their aggregated values. And that's it. That's in fact what we're doing for everything else. So it could be, for example, sentiment analysis. It would be done exactly the same way. We would take the maps of the individual sentiments for each sentence. We would aggregate all that together into an overall total of positive or negative sentiment. And we have our final value, which is maybe 80% is positive and 20% is negative sentiment. Okay, so now we're going to cover all of the stuff, all of the tooling that's built on top of HDFS. So Hadoop actually includes 2 databases that run on HDFS, HIVE and HBase. HIVE is basically kind of like a relational database, a distributed relational database running on top of HDFS. HBase is a column-based database running on top of HDFS. So you can see, both of them there. Again, I don't have time to describe all these things. That's for a class. So PIG is a language, a scripting language for MapReduce. A lot of people do not like, or they don't even have these expensive programmers that can write in Python and Java from scratch all these MapReduce jobs. So you can have actually data analysts writing in Pig Latin, which is what they call it Pig Latin language, which is a scripting language to write MapReduce jobs. And that saves them tons of time. It saves them tons of money. HCatalog is where all this data is being stored. It's kind of like the metadata for everything that's running on top of HDFS. Okay, And I think I mentioned earlier about data ingestion, right? So the two main tools that come with Hadoop for data ingestion are Scoop and Flume. Scoop is usually for databases, and Flume is usually for flat files. Okay, now, how do you manage that cluster? So if you want to manage your MapReduce jobs, you can use Oozie. So you can schedule them. You know, I want to run my batch MapReduce job at 2 a.m., right? So you can, every day. So you can schedule that using Oozie. Chakwa basically is kind of like a massive monitoring system for Hadoop. And, you know, as the name implies, it's kind of like the Nagios, you could say, for Hadoop. I don't know if that's a loose analogy there, but it works. I don't know if you guys know what Nagios is. But anyway, I'm assuming you do. Zookeeper is kind of like Yarn. So Zookeeper and Yarn are kind of related. Zookeeper is kind of older and Yarn is newer, but they do the same thing. They do resource management of those resources, meaning those individual nodes in the cluster. So like, for example, you know, if a node goes down or if there's a data error or whatever, Zookeeper will alert the name node or the job tracker for HDFS or MapReduce and say, hey, you know, don't use this guy, use some other guy. Okay, so we can also do machine learning on Hadoop. For example, we can do Apache Maut, or we could do Spark MLive, for example. So this is where we can do recommendations, clustering, classification, market basket analysis, blah, 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 blah. All the machine learning stuff. Okay, so, you know, suffice it to say there's a lot of crap out there. But the only reason is because, you know, now Hadoop is, I think, already, you know, over 10 years old. You know, there's a lot of stuff. So we don't have time to go through all of this. But again, it kind of falls into those general categories I talked about, which is data ingestion or NoSQL or data visualization or data analytics. Okay, let's talk about some of the companies providing Hadoop solutions out there. Hadoop is really big, so a lot of companies have said, okay, let us help you out. You know, I think very few people are going to go to Apache and download all these tools individually and try to combine them together, right? That would be hell. So companies like Cloudera, Hortonworks, MapR, DataStax, whatever, provide different types of solutions. So some of them, like Cloudera, MapR, and Hortonworks, provide Hadoop Spark solutions. Some of them provide NoSQL solutions. Some of them provide data analytics solutions. So there you go, right? So I'm not going to go into it. Well, I'll tell you one thing. The most popular one is Cloudera. So Cloudera is kind of like the Red Hat of big data. And they have a solution called Cloudera Distribution for Hadoop, and it has a bunch of stuff in it. Okay, so here is the architecture, again, for a typical kind of Hadoop cluster. So we could imagine like setting something up, like something like this. So, you know, just take a look at it and say, okay, well, you know, this is how you could set it up. But this is not a class on Hadoop administration, obviously. But, you know, if you were doing it, then this would be useful. Okay, so anyway, so that's it. Hadoop is basically parallel storage and compute for batch processing. Batch processing means it takes a lot of time to do stuff, and we do it in batches. So it's great if you have tons of data, right? On the file system, we can do batch processing. Well, what if we want to give a voucher to someone surfing our website? Well, we can't do that as a batch job, right? We have to do that as a real-time thing. So maybe based on the clickstream data or the web analytics data, we figure out that this guy is shopping for skis, right? It never snows here in the part of the world that I'm in, but I'm pretty sure it's ski season over there somewhere. So let's say he's shopping for skis, right? Well, let's say we want to give him a discount, you know, on ski, you know, accessories, right? Ski masks and all that stuff. So we can have a voucher show up right on screen. Now he'll be surprised, like, hey, wait a minute. How did you guys know I'm, right now shopping for skis? So you can do all that using Spark. So Spark basically allows you to do real-time processing rather than batch processing. And what it's doing is it's streaming that clickstream data and automatically learning from it and making a recommendation right then and there. So that's a pretty big use case for Spark, and that's the reason why we'd want to use Spark. I think I'm coming pretty dangerously close to my end time, so I'll have to hurry up a bit. So the real reason we use Spark is because of real-time processing. So you can see that that's the benefit. And this is Spark versus Hadoop. So as I said earlier, that it's mostly for real-time processing. Um, yeah, I'm not gonna go into it too much. You can read it. So what about Spark and Hadoop? How do they work together? Is it Spark versus Hadoop? Is it Spark plus Hadoop? What is it? Well, the good news is that you can use Spark on top of Hadoop alongside Hadoop. So if you need to do real-time and batch processing, hey, they work great together. You could use Spark to replace Hadoop too. But most people don't actually do that. In my company, actually, we did that, but because we had a lot of real-time batch processing requirements, like fraud detection and all that crap. So, but you don't have to do that at all. You can make them work together alongside each other, handling different types of loads, batch versus real-time. Okay, so what are the features of Spark? Well, speed. Spark runs 100 times faster than MapReduce and Hadoop. Why? Because it's in memory. It's actually loading into RAM. Spark is polyglot. What does that mean? It supports a lot of languages. So you've got, Python and even R and Java and Scala and all that stuff. You have advanced analytics with Spark MLib, which is a library that comes with Spark. You have, as I said, it's in memory. You have Hadoop integration, and yeah, so we covered all that. So what is the Spark ecosystem? As I mentioned earlier, we've got Spark MLib, which is the machine learning library. We've got Spark Streaming, which is the streaming library. But we've got other stuff too. So starting with Spark 2.0, we've got like Spark SQL to analyze the data frames. You can actually do queries, real-time queries, right there on the fly as you're getting in data into Spark. And you can filter all that, right? So if you're only looking for certain stuff as you're ingesting a stream, hey, you can do that. Then there's graphics and Spark R. And I'm not going to go through all that stuff. It's graph, like Neo4j stuff. Then there's Spark architecture. How does it work? It's basically running on top of Hadoop's infrastructure. So it's using the data nodes. Okay, so again, I'm not going to go through all of this stuff, but Spark basically is running on top of Hadoop. Okay, so Spark Streaming is what I said earlier. Streaming basically is you're constantly getting data. You're constantly getting data, and you can react to that data, right? So the data is really never stopping. It just keeps on coming. So we can do Spark Streaming for IoT data, right? For example, for temperature data or something like that coming in all the time. Or for e-commerce transactions coming in all the time, right? And so here's an example. So this is actually what I did actually in my application. What we did is we had a Kafka queue. We would use Spark Streaming to ingest from that queue, put that stuff through MLib, do some basic analytics, and then pump the output of that result into Cassandra. And then we did reports off of that, right? So that's how we, in fact, did our own Spark solution. Okay, now finally we're near the end, and we're going to be talking about jobs. I think I have like a couple of minutes or whatever to go through the jobs. So let's talk about big data roles. Basically, these are the dimensions. We've got the business dimension, the machine learning dimension, the programming dimension, statistics dimension, the so-called pure kind of mathematics kind of dimension, and the rest of it depends on what people are good at. So if you're really good at business and suck at everything else, hey, you can be a big data governance person or a big data manager. where you can manage the team and just focus mostly on business outcomes. But if you're really good with analytics, hey, you can focus on big data analytics, right? And then everything in between. So here are some of the job titles that you'd see available out there in the wild. These are only the top 5. There's like dozens of different types of big data jobs. So the first one is ETL, extract, transform, load. And that has a lot to do with data ingestion and data transformation. So you'd be using the tools that we talked about, like Scoop and Flume. You may be using other tooling, for example, to do the transformation. And then you'd be loading it into HDFS. Then we have Hadoop developers. So these are, people working using MapReduce, Pig, HIVE, HBase, all that stuff. Then we have visualization people like Tableau or QlikView. Those are really popular nowadays. So these are people who are visualizing the result of the analysis and showing it to the business, with the charts and all that stuff. And then there's data scientists. These are basically the jack of all trades people. They're doing the heavy lifting of the analytics portion. A lot of the machine learning, a lot of the statistical modeling, that's what these guys are doing. Interestingly enough, the data visualizers make more on average than data scientists. And there's a good reason for that. And the reason is because they're communicating to decision makers, strategic thinkers in the company, the C-level people, the board. So they're going to make a lot more money. Okay, so finally we have the OLAP developers, and these people generally make a good amount of money. These are U.S. of course figures. If you're another part of the world, this may or may not apply. OLAP is from old school, from data warehousing days, but it still applies in today's world. But now we're dealing with big data multidimensional cubes, right? So we're dealing with slicing and dicing massive multidimensional OLAP cubes. And that should be it. I should be done. We can take questions.
Thank you so much, Tarun. That was most informative, and we will get to those questions in just a bit. Just have a few more announcements to make from NetCom Learning. As we celebrate our 20th anniversary to serve you with the best-in-class IT and business certification training, we bring you unbeatable 20th year celebration offer this month to make your learning fantastic. We are actually offering up to 50% off on some of our popular courses. NetCom Learning also offers a comprehensive portfolio of big data courses, which you can see right there up on your screen, so don't forget to take advantage of those to supplement today's webinar. And team training can be customized and accelerated to meet your organization's specific needs. You can contact us today to be connected to one of our learning consultants to help advise you on your specific needs, or you can email us at webinar@netcomlearning.com, or simply search our catalog at netcomlearning.com. And we all know that technical skills are necessary to empower our careers, but do you need to improve or upgrade your leadership skills as well in order to accelerate your career? Along with your technical abilities, you can develop the skills you need to manage yourself, others, and business better. Welcome to Sartor Learning, a collaborative knowledge platform bringing the world's best business and leadership insights from Fortune 1000 leaders, best-selling authors, and Ivy League professors. Further, if you are interested in learning from the top American leaders, you can log on to our e-learning platform at sartorlearning.com and avail the special promotions meant for first-time users. Use your coupon code SARTOR10 to begin your leadership journey now. And right now, we do want to launch a quick poll to find out how many of you might be interested in taking some additional courses and training. So please just take a few minutes to fill that out before you all log off. And we also have a lot more informative webinars coming up. So please go to netcomlearning.com/webinars in order to register. And don't forget to follow and like our social media pages to get the latest technology updates. You can refer to our GoToWebinar chat window for all of our links on Facebook, LinkedIn, Twitter, and Google+. Okay, Tarun, are there any other final thoughts before we have to end today's session? Are you there, Tarun? You got any final thoughts before we end our session?
Can you hear me?
Now I can.
Okay. No, I didn't have any additional thoughts, but if there are no further questions, then I'm fine. I can stop talking.
Okay, well, great. Thank you so much for that informative webinar, and thank you all for joining us today. And if you do happen to come up with any additional questions, feel free to send them to webinar@netcomlearning.com at any time. We hope that you found today's webinar informative, and we look forward to seeing you back here with us soon. Feel free to tell your friends and colleagues about our webinars and other courses. Have a great day, everyone.